Hey guys, welcome to question FM296 of the Further Maths Fortify study guide. This question shows us this diagram here, minus the little strikes that I've put there, and says the graph above shows 8 activities, A, B, C, D, E, F, G, and H, which must be completed to finish a project. The number next to each letter shows the completion time in hours for the activity. Each of the 8 activities can have its completion time reduced by a maximum of 1 hour at a cost of $50 per hour. In the box below, write the least cost to achieve the greatest reduction in the time taken to finish this project. And then we're given a little box to put our final answer. It's got a dollar sign in front of it, so that's taken care of. Cool. So what we're going to start off with is a forward and backward scan, because we want to have a look at the float times and the overall completion time of the project, and then look at what we need to do in order to achieve the greatest reduction in time all over. So, put in this box here. So we'll start with A. So A is going to have an earliest starting time of 0, and then because A will take 7 days, C will have an earliest starting time of 7. B is going to also have an earliest starting time of 0, and because it takes 4 days, D has an earliest starting time of 4. Now, to look for the earliest starting time of E and F, we're going to have to compare the two completion times of this path here and this path there. So if we look at the path that takes B, then D, that's going to take 9 days all up, whereas the path that goes from A and then through A, then C, is going to take 8 days, which of course we take the larger of the two. So E has an earliest starting time of 9 days. F also has an earliest starting time of 9 days. Because E takes 2 days, G has an earliest starting time of 11. And because F has an earliest starting time of, it has a duration of 3 days, H's earliest starting time is going to be 12. Finally, in order to compare the finish, following the path that goes through E, then G, we're going to have a completion time of 19 days, and following the path that goes through F, then H, we're going to have an earliest completion time of 18 days. Once again, taking the highest number, we've got 19 as our completion time. Awesome. So, scratching these for now. So, working backwards, taking 6 from 19, we get 13, and then taking 3 from 13, we get 10. Taking 8 from 19, we get 11, and then taking 2 from 11, we get 9. Now, we have a choice here with D and C whether we work backwards from the latest starting time of E, which is 9, or the latest starting time of F, which is 10. We do the opposite when doing our backwards scan, so we take the lower number. So we take this 9 here, minusing 1 from 9, we should get 8, and minusing 5 from 9, we should get 4. Minusing 7 from 8, we should get a latest starting time for A of 1, and minusing 4 from 4, we should get a latest starting time for B of 0. So we can see that our critical path travels along B, D, E, and G. And these two alternate paths here, F and H and A and C, both have a float time of 1 along each of them. Now, the way that I break down this question in my head is by separating this into sort of two categories. So we've got this block here and then this block here. So, for example, the time that it takes to complete A and C as is going to take 7 hours plus another 1 hour. So we're looking at 8 there at the moment. Now B and D currently take 9 hours. I can reduce each of these paths, so B and D or A and C, by a maximum of 2 days. So that would involve, minusing 1 from B and minusing 1 from D would minus this by 2 days. So creating the maximum reduction I can in 9, in the longest path, I can get a shortest time of 7 by reducing B by 1 day and reducing D by 1 day. In order to create the same, because what would happen here, if we just reduce these two, A and C would take over as our critical path, and it would still take 8 days to complete this block. In order to get around that, we can reduce the activities along this path here by 1 day each. However, we don't need to reduce them both, because if we were to reduce A by 1 day down to 6, this path is now going to take 7 days also, which means that they share the critical path. Spending an extra $50 to reduce C, also to reduce this down to 6, won't actually have an overall effect on our project, because it'll still take 7 days to travel along B, then D. So far we've used 3 1-hour reductions. Cool. Looking at this next block, we have either E and G together taking 10 days, and we have F and H together taking 9 days. Once again, creating the maximum reduction that we can in this longest path, we can get it down to 8. So reducing E down to 1 day and G down to 7 days. That's only going to take 8 days now, which means in order to get our 9-day process here to match that, so that it doesn't swap the critical path and instead they share it, we just have to reduce one of our activities by 1 day as well. So doing a reduction of 1, we also get 8 days. So we should now have a completion time that takes 7 days and 8 days. So overall, we should have reduced our overall completion time by 4 days, down to 15 days in total. And in order to do that, we've reduced 6 of our activities by 1 hour at a cost of $50 per hour, which of course is equal to 300. So that is going to be our final answer, $300. If you guys have any questions about this, please drop them in the comments below. Otherwise, I will see you in the next video.